Welcome to BVS PRAGATHI channel. In this session, let's have a look at multiplexers, demultiplexers, basic sequential circuits such as flip-flops. So as part of flip-flops, we'll discuss about SR flip-flop and D flip-flop. So what does multiplexing mean? The operation of sending one or more analog or digital signals over a common transmission line at different times or speeds is called multiplexing. So in a multiplexer, you have many inputs but only one output. So by applying the control signal, we can steer any input to the output. The circuit has n input signals, m control signals and one output signal. Let's have a look at 4:1 multiplexer. In this, you have 4 inputs D0, D1, D2, D3. Then 2 control signals A and B and one output. Okay, and it is realized using 2 NOT gates, 4 AND gates and 1 OR gate. Okay, when A is 0, B is 0, if you see there, D0 is T to the output. Okay, and when D1 is equal to 1, when A is 0, B is 1, D1 is T to the output. When A is 1, B is 0, D2 is T to the output. Okay, when A is 1, B is 1, D3 is T to the output. Okay, now let's have a look at demultiplexers. So before that, where do we use these multiplexers? We use these multiplexers in communication system for data transmission. Demultiplexers. Demultiplexers convert a serial data signal at the input to parallel data at its output lines. 1:4 channel demultiplexer. In this, you have 1 input, 2 control signals and 4 outputs. So when A is 0, B is 0, D is T to Y0. Okay, and when A is 0 and B is 1, D is T to Y1. When A is 1 and B is 0, D is T to Y2. When A is 1, B is 1, D is T to Y3. Okay, this is about demultiplexing. Now let's have a look at the sequential circuit, that is flip-flops. So where do we use these flip-flops? Flip-flops are also called latches. We use this in shift registers, counters. Okay, and flip-flops has 2 states. So one is the complement of the other. So flip-flop is basically a memory device and it has 2 inputs. RS flip-flop has 2 inputs. One is set and one is reset. Okay. So here the RS flip-flop is designed using 2 NOR gates. The output of one NOR gate is the input to the other. So the output of one NOR gate is the input to the other. So what is the truth table of NOR gate? We see that in a NOR gate, when one of the input is high, Q goes low. Okay. So as part of that, if R is 0, S is 0, a 0 at input of a NOR gate has no effect on its output. Flip-flop remains on its previous state. The Q remains unchanged. Now if R equals to 0 and S equals to 1, what happens? Since S is 1, the output of NOR gate B goes low. Since this is low, this is one of the input to NOR gate A and R is 0 any which ways. So what happens? The output goes high. So when S is high, Q is high. That is the set state. Okay. Now when R is 1 and S is 0, what happens? The output of NOR gate A goes low. So since this is applied to as input to the NOR gate B and since S is 0, what happens? Q bar goes high. So this is reset state. Now when R and S are both high, what happens? Q and Q bar go into low state, which is a forbidden state, because the basic flip-flops operation is that one is the complement of the other. Okay, so that is what is explained in this. So I have discussed about the second condition where R is 0, S is 1. Then I have also discussed about the third condition, R is equal to 1 and S is 0. And the fourth condition is S is equal to 1, R is equal to 1, which is a forbidden state. So RS flip-flop is called a latch or a bistable multi-vibrator. D flip-flop. D flip-flop is also called delay flip-flop. Okay. Here the input is passed to the output after some time delay. So here the forbidden state of RS flip-flop is avoided. Here there is only one input. This input is inverted and given to the other gate. And clock is applied as input to both the gates. Okay, this is AND gate and it's applied as clock as input to both the gates. Okay, so when Qn is high, when Qn is the previous state, Qn plus 1 is the current state. When Qn is 0, D is 0, Qn plus 1 is 0. If D goes high, it goes high. If Qn is 1 and if D goes high, Qn plus 1 also goes high. Okay. So now let's have a look at some more properties of D flip-flop. So flip-flops are devices that uses a clock. Here the flip-flop has two inputs. One input is a control input. For D flip-flop, the control input is labeled D. The other input is the clock, which is a positive edge. Here it is a positive edge triggered clock. Okay. And we have discussed about the truth table any which ways. Okay. Now let's go ahead and look at the applications of D flip-flop. The D flip-flop is used as frequency divider or binary divider. It is also called divide by 2 counter. Let's see why it is called divide by 2 counter. So here is a D flip-flop. Here is a D flip-flop. Okay. So we see that this is a positive edge triggered clock. Now Q bar is fed back to D. Now let's say at the start, when the clock goes high and say D is high, the output also goes high. And this continues in the state until the clock again goes high. By the time the clock goes high, what happens? Q bar is applied to D. Okay. Now the output goes low. And this will continue to remain in that state until the clock goes high. Now once the clock goes high, now this is high now. This is applied over here. Again, the output goes high. So this is repeated. Now see that the clock has a time period T. And the output time period is twice that of the clock. Okay. Now so what is F? Frequency is equal to 1 by T, right? So the clock, we see that way the clock frequency, calculate the clock frequency and also calculate the output frequency. We see that the output frequency is half that of the clock frequency. That is the reason why we call this D flip-flop as delay flip-flop. It is also called frequency divider because it has divided the frequency by 2. It is also called divide by 2 counter and it is a binary divider. Okay, so what all did we discuss in this session? We have seen about multiplexers and demultiplexers, which are combinational circuits. And we have seen that multiplexers can be used in communication systems. Okay, and then we have gone ahead and discussed about flip-flops, which are sequential circuits, where the output is dependent not only on the current input, but also on the previous state. And as part of flip-flops, we have discussed about SR flip-flop, and we have seen that the disadvantage of SR flip-flop is it has a forbidden state. Okay, and that disadvantage is overcome in D flip-flop by having only one input. So D flip-flop is also called delay flip-flop, and D flip-flop can divide the frequency into, can divide the frequency by 2. So it can be used as frequency divider, a binary divider. It can be used as divide by 2 counter. Okay. So in the next session, we'll discuss about T flip-flop and also JK flip-flop. That's all for this session. More in the next session. Thank you. Thanks a lot and I wish you all the best.